we're going to be going over how to convert flood and ebb from one location to another. We're just going to be converting to Emeryville, and I already wrote down all the times you have to convert to. This should be in your paper during your test or during your homework. It's important to keep in mind that when we're converting events, we only care about events during the workday. So just we're going to go 0600, so 6 o'clock to 6 p.m. And these are going to be the only events we care about in between these time periods. So the first event that we have to worry about is a flood event. So that's going to be at 2:54 a.m. in the original location. But for Emeryville, we're going to be converting it, adding 2 hours and 10, or subtracting 2 hours and 10 minutes. So so for subtracting, the first thing we have to worry about is a ebb current at 9 o'clock. So we're just going to take 0907 to 907, and then we're going to subtract, since it's an ebb, we're going to slap 2 hours and 6 minutes on it. This will give us 0701, 7:01 a.m. And then to calculate the velocity of the ebb, we're going to take the flood, which is negative 2.6. And then we're just going to multiply it by the ebb factor, which is 0.7. Which will give us negative 1.82 knots. And then you have to write E next to it because it's an ebb current. And so for the first tidal event we worry about, it's going to be 7:01 a.m. with negative 1.82 knots, and we put E for an ebb. If we just calculate an ebb, the next tidal event will be a low tide, which is going to be at 2 p.m. at the original location. But since it's a low slack, we're going to be subtracting 4 hours and 9 minutes from it. So it's going to be 1407 minus 409, which will give us 958. So then the next, and since this is just a tidal event, or this is a slack current, we have to write either it's a high or a low tide. In this case, it's a low tide, and we know it's a low tide because the water just left. And so 958L, and then this is our answer for that. For the third tide that we're worried about is going to be a flood because we just had a low tide, so now the water has to come back in. The next low tide will be at 17, or the next flood current will be at 1713, so 5:13 p.m. So we're just going to write 1713. And then we're going to have to subtract, so the flood is going to be 2 hours and 10 minutes earlier in our location. So we're just going to do 0210, and we're just going to subtract this, so then we know that it's going to happen at 15:03. So now that we have that, we still have to calculate the current, or the tide flow, which is going to be 1.5 times the flood factor, which is going to be 0.9 in this case, so times 0.9. That's going to be 1.35. And then since it's a flood current, we're going to have to write 1.35F to show that it's a flood. An easy way to also find out if it's a flood or an ebb is ebbs will always be negative and floods will almost always be positive. And then it's getting near the end of the workday, so we only have one last tidal event to worry about, and it's going to be a high tide at 21:11, so around 8 o'clock. 11, And then we're just gonna have to find the high tide. So high slack will be 3 hours and 18 minutes earlier in Emeryville. So we're just gonna have to subtract 318. We're just gonna get 1653. So our tide event is gonna happen at 4:53, and then we're gonna have, and since it's a high tide, we don't have to calculate velocity because there is no velocity, so we can just write 1653 H for high tide. So there is one more tidal event left for the day, and it's gonna be an ebb current. So we're just gonna have to add another segment. And then we're just gonna see here, it's gonna be at 22:52. But in Emeryville, it's gonna be happening 2 hours and 6 minutes earlier. So then this is gonna be happening at 20:48, which is past the workday, but it's still important for us to write it down, just because this event will be going on during the workday. It's just the peak will be after. And then we're just gonna have to calculate the rate, so it's gonna be -1.3 times the ebb factor, which is 0.7. Then we're just gonna multiply that together. We're going to get -0.91 knots for the thing, for the tide event, and we're just gonna have to write E for ebb. And then I'm just gonna tidy this up so we worry about this. Right. So for the workday, the first event is going to be at 7:01 a.m. It's going to be an ebb current that's going away from the shore at 1.82 knots. The second event will be a low tide at 9:58 p.m. The third event will be a flood current at 3:03 p.m. and it's going to be traveling at 1.35 knots towards the shore. And then the event after that will be at 4:53 p.m. and it'll be a high tide. And then the final event will be at 8:48 p.m. and it's going to be an ebb current with a -0.91 knots away from the shore. If you have any further questions, feel free to reach out to Professor Reyes or any of the TAs, and we'll be happy to answer it.